The following video is all about problem solving by unit analysis. In chapter 2, in chapter 2, one of the main things that we do is study the use of converting from one unit to the next. Now, this can take on lots of different forms. In the earlier sections that we used for warm up, we may have seen simple unit conversions, maybe converting dollars to pounds or um, feet to miles. Now we're going to take it another notch, step it up another notch, and we're going to do multiple conversions at one time, and also look at conversions of rates. These processes mean that we have to be a little bit more organized when we set up problems. So you may have already had a method in mind for unit conversion, particularly ratio and proportion is one that many students use coming into the class. You may find that in the section they have limitations. So I don't want you to completely change your strategy, but if you have something that has been working in the past and you start working on problems that it does not work for anymore, go back and start learning this new method where we're going to make a train of multiplication of fractions and allow units to cancel in order for us to convert from one unit to the next. The good news about using this method is it's very organized. So it's a lot easier to see what comes next in terms of how to set up the problem. So in this section and in its continuation in 2B, we're going to learn about the use of units. We're going to talk about keywords and operations with units, and then we're going to use unit analysis to solve problems. So what are units? Here's a nice cool representation of a four-dimensional cube, but the idea of all of these is that units are complicated. They allow us to organize things in terms of how much it may weigh or how much time may pass for something to occur. Right? Units can be of distance. They can be of time. They can be of weight. They can be of storage and memory. I mean, there are a number of different ways that we can measure things, but we use those units to kind of categorize how big or small something is. Sometimes when we have a familiarity with a particular type of unit, but not familiarity with another type of unit, it's hard to visualize where we go. For example, if I tell you that something weighs 20 pounds, you can kind of get an idea naturally of what 20 pounds is because we've been working in pounds our whole lives. But if I tell you something weighs, I don't know, 70 kilograms, it's much more difficult to kind of get an idea of where that is in comparison to 40 pounds, right? Obviously, 70 kilograms is a lot. It's like the weight of a person. So units, they have a description of what a quantity measures or what it counts. And so this is an example, 45 pounds right here. We have the quantity, which is the 45, and then the unit, of course, measuring pounds. What we're doing in this section is unit analysis, which is that process of working with units to help solve these problems. Here are our key operations, our keywords and the operations that we use for them. So when we see the word per, you're going to think division. So miles per hour, think about miles over hour. And in these division problems, we're going to represent these as fractions. And you'll see that here in just a minute. Anytime you see the word of or a hyphen in between two things, that means multiplication. So like kilowatt hours or foot pounds is another one where you're multiplying two units together. Square is, of course, something when you're raising it to the second power. So if I want to measure area, I'm multiplying the length times the width. The length is measured in feet. The width is measured in feet. And so the area is measured in feet squared. Similarly, cubic would be measuring the volume inside of a container. If you want to find out how much volume is in there, then you're multiplying all three dimensions, the length, the width, and the height. When you're multiplying those, you want them to be in the same unit. Assume they're all in feet in this example. We multiply those out, we get an answer that's in cubic feet. I will say for the square and the cubic, make sure that when you write out the conversion, you write it out first in the first power, and then you raise things to the second or third power. Will be an example of that here in our practice problems where I can show you how to convert in that way. The most important thing to unit conversions is understanding conversion factors. So a conversion factor is like a fraction that we use to represent the relationship between two things. In this example I have below, I wrote down the relationship between inches and feet, that 12 inches is equal to 1 foot. We can write that statement in an equation like we did right here, or we can express it as a fraction. And when we're doing unit conversion, we always want to express it in a fraction. Now, this fraction can be written in one of two ways. I could have inches on the top and feet on the bottom, or I could have it the other way around, feet on the top and inches on the bottom. The layout of the problem will dictate which one of these two we're going to use. We always want units to cancel diagonally, and so we'll set up these fractions with the intention of canceling units. That's what will allow us to make the decision whether we should be using this fraction right here or its cousin, the reciprocal. Let's start with this first one. Says you are buying 40 acres of farmland at a cost of $14,500 per acre. What is the total cost? So on your own, you can go ahead and work on this problem. I'm going to switch my screen over so that we can work on this one together. So the important information that we know is that we're looking at 40 acres of farmland and it costs $14,500 per acre. So we're going to start by writing out 40 acres. That's what we're buying. And I also like to make each one of these a conversion factor. Now, this first one, there isn't a relationship that you're making with acres. They were just, that was the starting value, 40 acres. And so if you're not given a fraction, you can always make a fraction by expressing it over one. And so this is our starting value, 40 acres over one. Now we want to make this conversion from acres to dollars. And we have a relationship between acres and dollars. They told us earlier in the problem, 40 acres is equal to, 1 acre is equal to $14,500. So for every acre that we buy, we pay 14 grand, 14 and a half grand. So we want to take these two pieces of information, acres and dollars, and express them in the fraction right here. In order to do that, we want our acres units to cancel out. And so because I have acres on the top here, I'm going to make sure that I have acres on the bottom here. Remember the relationship? 1 acre is equal to $14,500. Now you may have already known at the beginning of this problem just to multiply 40 times 14,500. But what this setup shows us is that we can make sure that we're checking our answer in this way. For example, if we multiply right now, we have acres on the top here and acres on the bottom here, which cancels each other out. The only unit that's left in this problem is in dollars. And so when we multiply across, we make sure that our answer comes out in dollars, which is exactly what we want. We wanted the total cost. So we multiply 14,500 times 40, and we get $580,000. On we go. The next question asks, does the following situation make sense? It says, I can run a mile in 11 minutes, which is equivalent to running 15 feet per second. So the question is, does this statement make sense? So what you want to do is you want to make a conversion here from either feet per second to miles per minute or vice versa. So on your own, try to work this out. You can even pause the video and then I'll work it out with you. So for the second question, we want to make this comparison between miles per minute and feet per second. And so what I recommend doing is, before we do that, on these problems, I would always give you a relationship if you needed it. And so in this particular problem, we don't know the relationship off the top of our head, or maybe you do, between miles and feet. But I will tell you right now that 1 mile is equal to 5,280 feet. And so we want to make a conversion here. I recommend starting with what they were giving you in the beginning, which is a distance over a time. 1 mile over 11 minutes. What I'm going to do is I'm going to end up converting the mile portion of this into feet and the minutes portion of this into seconds. And then I can compare it with feet per second. So in order to do this, I'm actually going to need two different fractions, one to convert miles to feet and one to convert minutes into seconds. It doesn't matter which one you convert first because these are all multiplication, but I'd like to convert the mile into feet first. I have a relationship here that 1 mile is equal to 5,280 feet. And so I'm going to use this and get the mile value to cancel out. In order to do that, I want to put the mile on the bottom. If I have 1 mile on the bottom, then 5,280 feet is going to go on the top to make my conversion factor. At this step here, if I was done, my mile units would cancel out and my final unit would be in feet over minutes. But I want to compare it to feet per second. So I have one more conversion to make. I want to convert minutes into seconds. I know that 1 minute is equal to 60 seconds. And so in this fraction, 1 minute and 60 seconds will go on the top and on the bottom. Which goes where, you ask? If I have minutes on the bottom here and I want it to cancel out, then I'm going to put minutes on the top up here. You always want those to be on opposite areas or opposite locations, numerator and denominator, so that those units cancel out. 1 minute on the top, 60 seconds on the bottom. This part is so rewarding for me. I cancel out the miles. I cancel out the minutes. I verify that the unit I have left is in feet on the top and in seconds on the bottom. And now I multiply straight across. On the top, I multiply 1 times 5,280 times 50, there's times 1, which is 5,280. On the bottom, I have 11 times 1 times 60, which is 660. We want to simplify this completely. So in my calculator, I'm going to divide 5,280 divided by 660. I get exactly 8 feet per second. So it turns out walking a mile in 11 minutes is the same thing as walking 8 feet per second. The original problem asked, does this make sense? Is it equivalent to walking 15 feet per second? And in this problem, you would just simply answer, no, it is not. 1 mile in 11 minutes is equal to 8 feet per second. And on we go. The third one says, Portia and April take a 3,000-mile cross-country trip in their own cars. Portia has a 12-gallon tank and averages 40 miles per gallon. April's car has a 20-gallon tank and averages 30 miles per gallon. How much money will they spend in gas for this trip? And so what we want to do is we want to make some conversions here. Notice what we want at the end right away. It's probably a really good thing because this problem has a lot of information in it. And so we have to kind of parse some things out. The first things I would mention is my end result, I want money, right? So my final unit should be in dollars. We also know that the trip is going to be 3,000 miles. Of course, the longer the trip, the more money you're going to have to spend on gas. And so we know that 3,000 miles is going to be important here. Then they gave us some information about the gallon tank. And then averages 40 miles per gallon. So let's try to put all that together and see. Oh, there's not a gas price on here also. We also need a gas price, which I usually update each time. So let's make a gas price. Let's say gas costs $2.75 per gallon. And now from here, let's put this all together. Sometimes they give us information that may be a little bit extraneous or unnecessary. And so this case, they did give us a little piece of information that we didn't need. It doesn't matter how big your tank is in terms of how much money you're going to have to pay for gas. All that the gallon size tank matters is how often you're going to have to go to the pump to fill up. So in this case, we actually don't need to know how big the tank is. All we need to know is how far you're going, how efficient your car is on with the fuel that you give it, and then of course how much you pay for each gallon. So let's try to set this up. We're going to start with the distance, which is 3,000 miles. Oh, let me switch this over. 3,000 miles over 1. And then we're going to find out how many gallons it's going to take you to drive 3,000 miles. So we'll start doing this for Porsche. Remember, we have 2 of these we have to do. For Porsche, we know that the fuel efficiency is, we know that the fuel efficiency is 40 miles per gallon. And so the conversion factor for that looks something like this. 1 gallon, 40 miles. The reason why I put miles on the bottom here is because I started with miles on the top and I want these units to cancel out. So if I were to multiply right now, my final answer would be in gallons because my miles units would cancel. But remember, I want my final unit to be in money. So I'm going to make one more conversion that allows me to relate money and the gallon, so price per gallon. Again, I have gallon on the top here, so I'm going to put gallon on the bottom. I'm going to put the price on top. Here I just made up $2.75. Let me multiply. On the top I get 82.50. On the bottom I get 40. And so Porsche is going to spend $206.25 for the trip. Then we do the same thing for her friend. And the only thing that's different for her friend is the fuel efficiency. Instead of getting 40 miles to the gallon, April's car only gets 30 miles to the gallon. So we start with 3,000 miles over 1. Then we multiply by the fuel efficiency, 30 miles over 1 gallon, 1 gallon over 30 miles, because we want the miles units to cancel. And then multiply again by the price. And we get $275 for April. And so one of the things you'll do in this section a lot in the unit conversions is discuss the comparative aspect of these. So I could ask a question like this and say at the end, how much more money does April pay than Porsche, right? So you've done these 2 conversions and then you could simply subtract the larger value minus the smaller value to kind of get like a culminating answer. So that appears to be it. That's our last example. Thanks so much for hanging out with me in this nice video. The next video will have more examples of unit analysis, maybe a little bit deeper, but it covers basically the same concepts.